Let us do a problem based on force between multiple charges. So the problem is, consider three charges Q1, Q2, Q3, each equal to Q. At the vertices of an equilateral triangle. Equal to Q at the vertices of an equilateral triangle of side L. What is the force on a charge? What is the force on a charge? Capital Q with the same sign as Q. So they are all like charges placed at the centroid of the triangle as shown in the figure. So I'll draw a figure, equilateral triangle. So we know equilateral triangle is 60, 60, 60 degree, all angles. So here it is given ABCD. ABC and center instead of G, let us mark O. So let me draw this one. So this is equilateral triangle, though in my figure this AB looks slightly longer than AC, but consider this as an equilateral triangle. So the charges are given. So this is Q1, Q2, Q3. So all these charges are equal to Q. So given Q1 equal to Q2 equal to Q3, and all these are all equal to Q. Similarly, so at the centroid O, there is a charge Q. So it has same sign as that of the Q. So that this is also a positive charge. So now what we have to consider? We have to consider the total force acting on Q. What is the force on charge Q, which is placed at the centroid of the triangle as shown in the figure? So O is the centroid. So we will try to solve this problem. So I will draw the same triangle once again, so that I can mark the forces. Slightly bigger I will draw because I can mark all the forces neatly. point, I have drawn the lines from centroid to each corner. So this is A, B, C. So the length of the triangle is given L. Length of the triangle means the length of each sides. The sides are of length L. So here the line AD is perpendicular to BC. So when we draw line AD perpendicular to BC, we get this angle as equal to 30 degree. Now the first thing is we need to find out the distance between these charges, because in the force equation we have to write Q1 Q2 divided by R square. So let us find out the distance between the charges to the centroid. So we need to find out the distance AO equal to what, BO equal to what, CO equal to what. So the distances are important because to find out the force we should know the distance between the charges. So because O is the centroid, we can write AO equal to BO equal to CO. Now we will find out AO, BO, CO in terms of the given length L. So from triangle ABD, so in triangle ABD, consider this triangle ABD. So we can write cos 30 is AD by AB. AD by AB. So from this we can write AD is equal to AB into cos 30, and given AB is L, so L into cos 30. So we know the value of cos 30, that is root 3 by 2. So we get AD equal to root 3 by 2 into L. So AD is equal to root 3 by 2 L. But our aim is to find out AO, BO and CO. So because O is the centroid, we know AO is equal to 2/3 of AD. Because O is the centroid, so AO equal to 2/3 of AD. So this is equal to 2/3 into root 3 by 2 into L. So this value is equal to 2/3. So this is 1 by root 3L, not root 3. So 2 will get cancelled. So 2 will get cancelled, and root 3 will get cancelled with 1 root 3. So we will get L by root 3. So L by root 3. So by symmetry, or because O is the centroid, we can write, so by symmetry, AO is equal to BO, which is also equal to CO equal to divided by root 3. Now let us find the force one by one. So force on F1, force on, or force F1 I will write, force F1 on Q due to charge Q at A, which is equal to F1 is equal to 1 by 4 pi epsilon naught into Q into Q divided by R square. So R square is nothing but L by root 3 whole square. So this value is equal to, so we will get root, this we can write it as 3 Q divided by 4 pi epsilon naught L square. And this force will be acting along OA. Along AO. So the force F1, if you see, I can mark it in the figure. So here is the figure. So F1 due to the charge Q1. So this will be acting along AO. So this Q and Q1, if you see, they are like charges, so they repel each other. So this force F1 will be acting like this. Similarly, all the other forces F2, F3, the magnitude, if you see, they will be equal because all the charges are equal. So we can write here force on force F2 on Q due to charge Q at B is also equal to 1 by 4 pi epsilon naught L square. So the magnitude is same only because all the forces are equal, and this will be acting along BO. So force F3 on Q due to charge Q at C is, again the magnitude is same, along CO. So let us mark these forces in the figure. So this will be F3. So F1, F2, F3. This will be F2 and this will be F3. So if you add F2 and F3 vector, you have to add all this, you have to take vectors M. So if you add F2 and F3 vectorially, so this force will be acting along AO. So it is equal and opposite to F1. So the addition of F2 and F3, the vector addition of F2 and F3 will lead to a force which is equal and opposite to F1. So then our net force now will become 0. So the vector addition of F2 and F3 will give us a force which is along way. So F1 is acting in downward direction, and when you add F2 and F3 you will get a force which is equal and opposite to F1. So this is F3, this is F2. So when you add these forces you are getting a force which is equal and opposite to F1. OA. So net force on Q at O is equal to F1 plus F2 plus F3, and when you add all this vectorially, so you get 0, because F1 is in directly downward direction. So when you add F2 and F3 you get another force which is equal in magnitude to F1 but opposite in direction. So when you add them, so all the net force will become 0. So the net force is 0.